Welcome to today's Monday live session. So again, we're going to go through launching GFX program from scratch. What kind of features do we have when we're launching the GFX program? Then we're going to be starting from a blank project. So Sab's going to take us nicely through, creating a very simple thermostat logic. And then we're going to go ahead and adding some fan sequences and things like that into the GFX program. He's going to go a bit more into a deeper dive. So today's going to be a lot of focus on GFX. So he's going to go nice and slow and steady, kind of working your way up to understanding and familiarizing yourself in GFX. So GFX is a very big tool. This is where a lot of people spend a lot of their time. Understanding the GFX program is very important. The great thing about the GFX program is that it can be utilized in any one of our controllers, from the ECB to the ECL to the Eclipse line. So it's a very important tool to understand and know how to use the tool itself, okay? So there's a lot of little nuances, a lot of nice features around it. So Sabatino will definitely walk us through that. So number one, we're going to go through our product architecture real quick. So if you look at the bottom, that is basically where our field devices live, right? So those are going to be kind of, you would say, the devices that live between the range of 127 to 255. Then we have our room devices, and then we go into the room controls, system equipment. From the system equipment and room controls, that's what we'll be focusing on today. That is where a lot of the GFX programming aspect happens. Those are the master devices. This is where a lot of that logic lives. So Sabatino is going to walk us through a lot of that and how all that works. And again, that GFX program is a unique software that lives on all our controllers. So if you're in the ECB line, EC stands for Easy Controls, B for BACnet, ECL for LongWorks, and ECY is the Eclipse series. So that is our BACnet IP line, okay? So without further ado, we'll get into it. So number one, I'll go through and we'll go back to the forum, Display Controls forum, and I'm going to show you where these live sessions are going to live. So those that have not registered into the forum, please do so. You can find that from our website. When you go to our website direct, you can go ahead and click on login. From login, you get into the forum. And there's one called video sessions. So those that did not make it to our Friday session, you can come back here and you can revisit right here. You can play directly from within the thread. It's the intro to Smart Installer, intro to the forum, and starting the GFX program and looking into code. All right, so this is where you're able to find it. Next, we're going to go into how do we get the GFX program. So this may be a little bit repetitive of what we did on Friday, but I'm just going to show those that are not there how to launch the GFX program and where to get it from. So we're going to launch the Smart Installer. From the Smart Installer, try to use the tabs on top, right? This is the All tab, so you see anything and everything. If I'm only focusing on GFX, I'm going to go ahead and click on GFX. In GFX, this is where I want to go ahead and select the GFX program. By right-clicking, you can unselect all and only select the GFX program. Automatically install files after download and click next. So you can go on to the next phase of installing the GFX program. Now, once the GFX program is installed, and those that have not installed it right now, I recommend you go ahead, go into Smart Installer and download the GFX program so you can follow along with Sabatino. Once the GFX program is installed, you can either scroll all the way down to Display Controls and then select the EC-gfx program, which is located right here, and it'll go ahead and launch the GFX program. Now, as you wait for it to come back up, for me, it launched right over here on another page. I'll bring it over here. And the first thing you'll be brought up with is connect to server. So what type of options do we have? We have the emulator, which is the first one. So emulator, if you don't have any controllers and you want to start engineering or playing with some code and debug the code, emulator is where you want to be. Okay, that means you're simulating an Eclipse controller. All right. The one below that now, we have BACnet Niagara. So if we select BACnet Niagara, what do we have? We have a direct connection. Okay, if you guys have some legacy sites, there's still tunneled connection. If you want to go through a different controller, you can do tunnel. Direct connect is you put in your IP address, so whether it's 10 20.50.121, for example. Your port is your GFX port 1931, your username and password. Okay, now your username and password, remember, you are going through Niagara, which means that it's asking you for the supervisor, or it's asking you for the EC boss's IP address, and then it's asking you for the username for your station. What it will do at this point, it will interrogate the EC boss and ask what devices does it have below it under the backnet network. And then from there, you can select whichever device you want, and it'll be able to open up the GFX program for that device. Next is LAN Niagara, exact same thing, except now it's going to interrogate the LAN network that lives under the drivers of your EC boss or supervisor that you have. Okay, you put your username and password, and you connect directly into that device. Next, we have LNS for those that still use LAN Watcher, LAN Maker. Hopefully, you guys are transitioning out of that and going into the BACnet IP world. But those that still have that, you're able to connect through an LNS server. You have whether it's a lightweight client, full weight client, you can connect into a LNS database if you need to. You can go on net or off net, those that are still familiar with it. Again, this is extremely rare, but those that have it, you can still use that. Now, if you are using the Eclipse series of controllers, you can connect directly to our Eclipse products, okay? So whether you have a secure connection, all Eclipse controllers come secure, HTTPS. You also have the standard HTTP if you disable that in the Eclipse controller. Then you put in your IP address of your Eclipse controller, which port, 431, obviously is a secure connection, right? Then you have your username and password for the Eclipse controller. So this is a direct connection to an Eclipse controller, and it will open up the GFX code that lives within that controller. Okay, so that is a REST connection. Anything that is Eclipse will be a REST connection. All right, and now again, if you want to simulate, you can go ahead and click on the emulator, and you can select whichever device you want to emulate. And what does that mean? It means that when you start adding IOs, let's say if you chose an S1000, you drag and drop in a damper, obviously going to say, well, you're not using the right, device model, and you'll have to go ahead and change it. So it actually is simulating the device, verbatim what you see right here. You also have access to ECB controls as well if you want to engineer a code for it, and then save that and send it to whoever it is in your team in order to use. All right, so I hope you guys have GFX installed. Let's go ahead and launch GFX. And I'm going to hand the dance floor off to Sabatino, who's going to take it over. And I'll go ahead and I'll stop my share. And I'll give Sabatino the spotlight. And Sab, go ahead and see if you're able to.
Great. Now, I'll be sharing my screen. You guys hear me? Perfect. Give me a second. I'm sorry about that. Seem to be not getting any kind of voice feedback. That's why.
All right. Sam, you hear me okay? Okay, everybody says it's good, so we're good. It's just eerily quiet. It's a bit weird. All right, so as Sam was saying earlier, you have that ability to launch that GFX straight from an Eclipse controller. We showed you how to do it through the web-based, but of course, you can always launch GFX straight from an Eclipse IP-based backnet controller. This is just showing you guys the benefit here. I'm not going to use it, just showing you that, you know, Eclipse GFX program is right there. You click it and it'll launch GFX straight from the web-based Eclipse IP controller. And of course, you have all the other. We're going to look into that later on, all the configuration later on in the week, or maybe next week. We'll see how far we get. Pretty sure we're going to attack the Eclipse controllers very soon. And then, of course, you enter your password and you get into the controller. So it's very seamless in the way that that controller can get accessed. But for now, today, we're going with emulator. We're going to emulate this kind of controller. So I'm going to close that out and close this out and back to emulator, which was simply starting it from the start menu or the desktop. So today, just going to get my notes out so I know which item to bring in first. Whoops. Bring that there. All right. And I'll work with the GFX tool. Again, we're going to look at properties of our project page, the project explorer over here on the side. I'm going to also pin those down so I always have them available to me. I'll do the same for the toolbox. I'll pin it down just like that. And so at the very bottom, you'll have code library, which we'll delve into later on. And the toolbox itself, this will be our palette, for lack of better words. There's palettes or toolboxes you can create yourself. And that's something a little bit more advanced. But in the help files, we'll show you exactly how to do that. We also have a little lab during training where it's optional. People can use that lab to build their own little items. But we're going to stay in the Distech Controls toolbox, which is the default toolboxes for all of our controllers. This toolbox will change slightly in terms of what you have available to you, depending on the protocol you're using. We mentioned that on Friday. So back on the project side, this is where you basically name your project. The file name. You'll basically rename it just like that. So if I want to call this a thermostat code, you're very welcome to do so. This will represent the whole project, the whole GFX tool itself for this controller. The page you see in the middle, this main view pane, which we can use this thumbnail to pan and scan. We can also use our mouse roller up and down, the side, the scroll bars, and if you use control, you can also zoom in and zoom out. And I'll try to be attentive to visualizations, and I'll try to zoom in while I'm teaching so you guys can see what we're talking about. The programming sheet. By default, the programming sheet has its own properties. So you have the properties of your project. So this is the very first section, the properties of your project. So we called it thermostat code, and we could pick from a list of enumerations. Now, this is something we could do after, but every enumeration that you would eventually create, if they're different from what already exists, you can import them straight into your project. So you get to bring in all your custom enumerations. We haven't created those yet, but you could bring those in. The measurement system, is it going to be in US or metric system? You could change the author name. You could punch in the controller type. You can put a description for your controller. Okay. Everything else will happen automatically. It'll give you a creation date, last modified by, last modification computer. So which computer did the modification? So if I were to just hit a save right now, this data should technically populate with information, unless there's not enough data yet. and that's okay too. We'll see it later, but there you go. So desktop, 3D, whatever, last modification date, who made the change, etc. Now I didn't put any description or controller type, but I can easily put that in here. Call this an S1000 and description small code create. This could be whatever, right? Air handling unit, 1 heat, 1 cool, 2 heat, 2 cool. You get to choose whatever you want. So that's up to you, and that follows you. Password protected, miscellaneous over here. This basically puts a password protection on your GFX code. So when you launch GFX, you will be prompted, if this was set to true, to enter the password that was required for you to see this GFX code. See and edit, of course. File, protect project is where that occurs. So if you were to create a project password, all right. And if I go back to my Project Explorer, properties, you'll see that now it's password protected. Next time I open this project, it'll prompt me for a password. Okay. Otherwise, start a brand new project and create a new one. I'm going to unprotect the project. Are you sure you want to unprotect it? Yes, and now it's been unprotected. Because I was logged in already, it doesn't ask me for the password again, and now it's no longer password protected. The page itself, whenever you click on it on the main screen, it'll automatically take you to the programming sheet. So if I were here, if I kind of click on a property like that, it takes me to programming sheet, even though it doesn't show that. It would be that here. So there's the programming sheet. Now it's 8.5 by 11, and you could name the sheet itself. So if you have a scenario where you're going to have multiple pages of product code, so maybe you're going to declare your inputs outputs on page 1, page 2 will control certain logic sequences for morning warm-up or economizer control, and page 3 would be heat cool mode, etc. Page 4, maybe you'd want to tackle network communications and requests and requirements from the network or from the other controllers. You could separate all that by naming your sheets. So I'll just, for this sake, we're just going to call it thermostat code for now, and that'll be the name of the sheet. I could add more sheets, add more programming sheets by just simply clicking add more programming sheet. Of course, in Project Explorer, you could duplicate sheets that are already existing, or if you right click on your project, you could add sheets as well. So you can predefine, edit, and manipulate whatever you need. The text document sheet, which is another item that lives in your project, and you can change its order. Okay, that doesn't change its order in tabs, and the tabs have no bearing on deleting those items. They still exist in your project. You just closed the view of those projects or of those views. So I double click and I'll get the views back. And that new text document, we could rename that. Maybe it'll be the sequence of operation, SOP. And you could then go and modify or edit whichever way you feel fit from within the tool itself. You could go into the properties of the text document. You could copy paste HTML based text. So if you were to simply go online and let's just grab something really quick. But we've seen an example of that earlier. Let's say we take a I'll just take the first hit. I don't care where I'm getting it from, but if I were to take that piece of text like that, you can just simply type it in. You don't have to go through pushing all that code in or that space manually. You could copy and paste from something you've already written. There are some other schematics we can also show, images we can also show, so that'll be into the items later on. This is all within the environment of the GFX tool. So you will launch GFX to see that sequence. You will launch GFX to see your code space. Let's change the size of our code space. Not that it's necessary, because there is a way to transfer data between pages. So if I were to have a secondary page, which we'll demonstrate that, I'll add a new programming sheet, and I'll make this sheet, I'll call it my my outputs. Okay, just for demonstrative purposes. And I'll take that thermostat sheet, and instead of using it in an 8.5 by 11 form factor, we can change that to any factor size we want. Same as printer, predefined or custom, you choose. Landscape or portrait. Of course, once you press OK, it'll change the orientation of the, it was landscape, there you go, portrait and portrait mode. So you get to decide how you want to create your code. I'll go with the predefined. I'll take an 11 by 17, so a lot more space to work with. But again, we could transfer data between pages. We're not required to, I'll do that again. Predefined, 11 by 17 landscape. There we go. Okay. Back into the toolbox. We'll start off with something very simple. Where we typically start is an input. There would not be any kind of limit other than what is on the hardware itself in terms of hardware inputs. For example, we just drag and drop a hardware input. And here it says that there's no hardware input currently defined by the I/O module of this S1000. So we're going to have to tell it which I/O module it has on board. And in here, because we chose a hardware input, we're only going to be shown hardware input type of objects that include hardware inputs, for example. So of course, 8UI6UO has some outputs on board, but we're only interested in the input. So we're going to bring in an 8UI6UO. This is 8 universal inputs, 6 universal outputs versus 16 digital inputs, 8 universal inputs, 6 digital outputs, triac mode, 8 universal inputs, and 4UI, 4UO. So 8UI, 8UO, we add that, and now we get this object, hardware input 101. The number itself represents which I/O module it's on and which number in the I/O module it exists under. We zoom this in a little bit so you get a better view. This will help out a lot of guys. Okay, I might have to zoom in and out a little bit just to get the space I need. But here we go, hardware input 101. So here we have the name of the object, and this is going to be the backnet name. So when you discover it, when you create it, that's the name it'll give it. Now, what this deck has done is we've removed all illegal characters as best we could. Now, we didn't make it foolproof. You might have a character in there that's not understood, and it'll just spit it out there. When you do a create points in Niagara, as we all know, Java-based data structures don't like to use spaces, dashes, decimal points, slashes, and all that. You want to avoid those to avoid escape names, and make your data as forward and backwards compatible as possible. And what we do is we just remove all the spaces in this case. And if you were to create points on this, it would just be hardware input 101, no spaces included. You could change the name of our object just by selecting it and start typing. So if I wanted this to be called space temp, all I got to do is select the object, and by default, we will create a name for it. So space temp, and there you go. Now the object is still hardware input 101. That's what tells the controller what this block is doing. The name is the backnet name we gave that point. We could give it a description, again, in the description field and the properties of it and all that. We could collapse it. Right now, there's no reason to collapse it. You know, you'd want to have a connection from it or whatever. But the collapse function is going to help us out later on because it'll retain all the features of the object without taking up this much space. It'll take a lot less space on the page. Now, the page, there's no real limit how many objects you can put on the page. You'll be limited by what the controller can handle for you. So the Eclipse controllers will handle, you know, soft limit of 2,000 objects. That'll include all backnet objects. Now, equal blocks, logic blocks, those don't really count. They're code space, they're code writing. So it doesn't really matter for those, but the objects themselves, around 2,000 objects, that's what we say. And so this page can be as big as you like. Of course, as we mentioned Friday, if you're deciding to print it, I hope you have a printer that can print, you know, a mile long page. So you probably want to use typical sized pages, and whatever data has to go from one page to the other, we're going to use something called a reference hub and target to create those between. Now, space temp 101, like we mentioned earlier, that's the hardware 101. It shows its status. It's disconnected. So in being disconnected, we're going to have to connect it somehow. We're going to have to tell it, what are you? What is your interpretation? You are 101 hardware input. And that's IO module 1, input number 1. If it was from IO module 2, it would be 201. So IO module 2, input number 3 would be 203, for example. That's the nomenclature on that. To set it up, we could simply double click it. Any double click on any object will always take you to the bold feature or the bold list item in the lists of actions here. So by double clicking, I will straight away go to configure. For example, if I were to bring out a logic block, an OR block, for example, and I were to double click, it would not be configured. There's nothing to configure, but it would be configure ports, and that's something we're going to look at later. But we're going to leave this here. We'll need it later on. So space temp, double click, takes me to configure. Now that's the same configure as this open configuration resources. And this is pretty huge. What this is doing is it's basically showing us all the objects, all the backnet objects, network values, PID loops, timers, calendars, etc., all in one location. I could multi-select, multi-configure, inputs, outputs, etc., by name, by duplication, by adding from a specific value, a specific number. For example, if I wanted to bring in a variable, it would be an object value, an analog value here, for example. If I wanted to bring in one, I could have just right-clicked and added, and that would give me the very first analog value that the controller would have. If I wanted to bring in with options, maybe I wanted it to start at 50 and brought in one up to 100, and that would have analog value 50, for example. Okay. We also have the ability to bring them in through the toolbox. So you click and drag, and that'll bring analog value 1. If I hold Control and I click and drag, Control, Option Control, there you go. I'm on a Mac, so I got to use certain options. Option Control, but in Windows users, it'll be Control. You'll have the option, just like we did with Add with Options. That's what we're getting here. quantity and start number. So if you want to bring in number 50, and there it is, number 50 is out there, and you could have brought in multiple objects there. So we're going to need one of these. So we don't need this one, we don't need this one. Okay, we're going to need one of those, and this will be probably our set point. Okay, I think I put a space. No, I didn't. Perfect. Set point and space temp. Let's go back into the configure here. Double clicking. Notice the items I added are still there, and I may or may not want to use them in my controller. At the end of all this, we can always show all unused resources. So whatever has not been brought out to the code space can be deleted. You could reevaluate, you could delete by selecting them and hitting delete, and that actually gets rid of them from the resources of the controller. And that's important because the controller will use a dynamic resource allocation. It'll create an object once you've added it. It'll exist. If it doesn't exist, you will never see it. So if I were to discover this controller, discover its points or create points, etc., I'm only going to create what I've saved, what I've brought into the controller. If I've brought in points and I didn't use them, you may get a lot of points that aren't doing anything in your controller. You may want to revisit this and remove all unused resources. And it's normal. It happens. We often play with certain items. We forget about them and we never go back. But it's a good code cleanup. So it's a really useful tool to do that. There's also this item called renumber, which is fairly recent, and that allows us to renumber analog values. If, for example, you created your code and you said, oh, you know what, I made a mistake. This set point on all my other code, that set point is supposed to be number 50, this one here. Well, I could go into renumber and say, well, you know what, your new number will be 50. And you could also multi-select them and say, well, 50 like that. It has to exist, has to not exist, so 51. And then you now have made that one 51, just like that. He's still called analog value 1 in a sense, but his real value is AV51, and he's called set point. So we basically renumbered that object. Let me bring it back. You could use things like Control-Z, and that'll bring back, delete whatever you've done. I would have had to have rebuilt and send that. So I'll just get rid of it and put this back like that. So this will be set point. Okay. So space temp, double click. Here we go. Our space temp object here. We have its name, description, and then the signal interpretation. We'll go with disconnected. We'll change that to, say, for example, something very standard, RTD thermistor. And then it will be given a backnet property object. So it's called analog input 101. Broadcast mode. Every backnet object can be able to broadcast its value over the network, either locally or globally. So you want to exist in your subnet or you want to exist over the whole network. Expose that. COV increment min send time. So if there's a change of the increment that we decide on, 1 degree Fahrenheit, 2 degree Fahrenheit, whatever it is, 5 seconds minimum send out time, 300 seconds maximum send time. So if there's no change, I will send out every 300 seconds. If there's multiple changes, for example, a morning warm up, scenario where you'll have a lot of space temperature sensors start to change values very, very often or very quickly. You want to throttle that down and, something like 5 seconds, 10 seconds, 15 seconds on min send time, or a higher COV increment. So you get to decide which granularity you want to work with. Personally, I would prefer with a fairly low COV increment, maybe 1 or 2 degrees, and you could start to play with your COV min send time, 5 seconds, 10, maybe even 15 seconds. But the defaults work very well for medium to small size jobs. There's no need to really modify those. It depends how big your job gets or what you're doing with your data. The signal interpretation, so we already chose that earlier, and that gave us options below here. So we're just going to scroll down a little bit. The selection for the thermistor type. Now we support PT1000, so platinum 1000, nickel 1000 at 0 Celsius, nickel 1000 at 22 Celsius. So that's like 32 and 72 or something like that. 10K type 2 and 10K type 3 thermistors. Now 10K type 2 are typically the preferred type for today's sensing needs, but you may have certain scenarios where you'll either run into an older site or a site that's using different sensor types, and those are our options. For a standard type of sensor interpretation, anything else, it would be up to you to create, and that would be either a custom thermistor or custom type of interpretation, or just custom. Linear is basically going to be used for linearization of an input. So 0 to 10 volts, 4 to 20, 0 to 20 milliamps, etc. That'll be your linear. And the options will change as you select them. So say, for example, I were to select linear. Okay, we'll have resistance 0 to 10, 0 to 20, 0 to 5. Can I do 4 to 20? Absolutely. Pick 0 to 20, make this a 4, and you're at 4 to 20 at this point, right? We'll just ignore what happens from 0 to 4. We're never going to get 0 to 4 because your sensor will only give us 4 milliamps anyway. Now this is jumper selectable on the controller hardware. So you could make it 0 to 20, 0 to 10, 0 to 5, or just resistance. By default, we'll send out 5 volts DC and we'll receive resistance from your sensor. We'll detect up to 350,000 ohms on board. And of course, if you have a 10K, you'll just put 10K there and you get to decide what you want to read on that sensor. Okay, the rest of these items here will be shared. So we're going to change our type here to something like custom. Now, custom is interesting because I'm not limited to PT1000, nickel 1000 of the 2 sorts, and type 2s and 3s, 10Ks. I can make my own type of custom interpretation. I'll click on this little button here, and it'll give me this table. Now, this table can be modified from here, and you could put up to 32 entries are allowed. You'll just keep adding your entries and entering your values. Now, if you make a mistake and put something that is outside of scope, the software does tell you. It says, well, this is not really following. You got to put these in the right order. So in this case, I would put them in the right order like that. And so that error goes away. For whatever reason. All right, so you get a good idea of how this works. Now this can be saved, it can be exported to a file, and that's a simple CSV type of file that you could modify yourself. I'll take a copy of it. I'll just call it export for now. Oops, I was doing import. Save to file. Export, it's an XML file type. put on my desktop, and you can modify that if you like outside of scope, outside of this tool. Very simply, right? You can even turn that into an Excel sheet. And as you can see, you just keep duplicating the lines until you get to 32 is your max. But that's outside the environment. Of course, that can all be done from within the environment. You just keep adding your fields. Once you have something good, you can export and you could re-import. Okay. This is a true BACnet COV. It's the object itself. It's not trying to realize or proxy with anyone else. It's communication on the bus. So if I tell it you have a 5-second throttle on your max send time, min send time, then you're not going to send anywhere faster than 5 seconds, even if you change more than that. And this is a good time to talk about, Niagara. If you have a Niagara-based environment where you're constantly asking points or controllers what their values are, take this into consideration that we're not going to tell you anything faster than 5 seconds anyway, and that's by design for easy use of network traffic. So that was custom. Digital, very simple. Digital, true, false, or you could change this type. You could call it on, off, yes, no, manual, auto, start, stop for a Boolean type of interpretation. Typically, you would use Boolean. You wouldn't use enumeration for, well, you could maybe for a hardware input, but not for a binary value, of course. And if this spacetemp was whatever, this input was set for something other than what you're used to here, you can also make your own by just going into enumeration and configuring your own custom enumeration. So we talked earlier about, importing a custom enumeration. You have some sort of special feature. You could add this enumeration, whatever you want to call it, and you'll add your members. So you could add a fixed value starting at 1, for example, for BACnet, or a range, anything from 1 to 5 or whatever, and you'll call it sequence 1 or whatever, and you can just keep adding your members that way. You could add sequences that enable ranges or a combination of ranges and values. It's your choice. Okay. I'm not going to save this or anything, but you get the idea. Typically, if I want to go with a run mode enumeration, and I will just call it stopped. We're going to go with the binary value type, and then we'll go with one called running, right? You could do that too. And then you'll have the mode you've created, the mode you want to create would be listed there. And so now this would say stopped or running. And had you set this up as digital, the object itself, once I hit OK, right click, oh, I pressed that button by accident. I went offline. Now that I'm online, I could write to the object itself, and the options I will get, of course, because I'm running an emulator, this doesn't show up. Should be overridden. It should have worked. No issues. We'd get the stopped and running as the option. Okay. Going back into the object itself here, multi-level. This will give us a similar style as we saw earlier with the custom, where you'll have your custom build, but you'll have to create your enumeration first and then fill out the interpretation. So your first reaction would be to click on this button, but you really have to figure out your output configuration first. So once you create your custom enumeration, say for example, we'll go to configure it, and this would have been something like fan speed, right? We could go with off, and then low, medium, whoops, high, and auto, right? Once we do that, we could then go back to the multi-level and figure out what the signal interpretation would be for that purpose. So if it was a 10K pot, something like this would be what you need, right? And now my options are off, low, medium, high, auto. All right, digital multi-level. We saw thermistor set point offset. This is another type. And you then would tell it what signal you're receiving, and you give it the min and max of that signal interpretation. So 0, 10K, -4 plus 4. You just put a negative there for -4. I'm sorry if it's small. This is the biggest size I can make it unless I change the resolution of my screen. But that's pretty much how you would set up your set point offset. And then finally, pulse. If you were on an input, you'd have a pulse type of signal interpretation. You'll have your falling increment, your rising increment. If you always want to pulse upwards, if you want to pulse up and down, you get to change that. Sorry, you're always pulsing upwards, but if you want to pulse on the falling and on the increment, increasing or just on the rising. So let's go back to thermistor because that's what we need. We'll scroll down a little more. Signal offset. You could offset your signal. Maybe you've put it near some kind of a window, or you're always detecting a higher temperature because of some other exterior source. You can offset it, negative 350,000 ohms to positive 350,000 ohms. You could offset the output itself in degrees temperature, Fahrenheit. You could give it a default value. So say I want to start off at 70 degrees Fahrenheit. No offset. Out of range management. This is for Eclipse controllers, we could have out of range detection. So if it's within certain values, it's normal. And if it goes beyond those values, it would be out of range. Using a filter, if you have a sensor that is constantly changing rapidly, so you have fluctuations of signal, you could use that filter to laminarize the signal. It kind of averages it out and makes it more stable. Use override. This is something that allows us to take advantage of a EC sensor or sensor that has those day-night mode setback buttons or override buttons. Basically, they shunt the resistance. By checking that, we pick that signal up and we'll pulse it to our override output. And by doing that, we could use that as a free input for anything else we want to do in code. Metadata, we'll talk about that later. That's really something for Envision, Express Envision. Alarm, we could turn on alarms for this object. All right, we have an inhibit point, which is going to look for a binary value that you would have added in your code. So you could depend on a certain condition to occur. And if that condition occurs, then inhibit this alarm or not. Otherwise, you just leave it with none and the alarm will be active on low and high based on whatever values you give it. So if I want to say, hey, anything higher than 80 is a high limit and anything lower than 60 is a low limit with a dead band, a time delay, and a time delay to go back to normal. Notify type, it'll be an alarm or an event. that changes what it looks like on the bus and how it's received. And then we have the events enabled, off normal to false to normal. Sorry. So we have here a kind of backnet formatting for the variable names. So how are we going to expose that data? So we go device object name, node object name, event state, and you could also add your other features. So if you want to also show the high limit, show the low limit, etc., you could do whatever you want on those exposures. Notification class, you then create a notification class. This is going to be internal to the controller. If you don't give it a class, it's still going to be inside the controller. But by giving it a class, you could tell it to go somewhere else. I can tell it to go to an email. So I will set up an email configuration, email client configuration rather. I'd log into some email account. Typically, we recommend using Microsoft's or Outlook or your company portal's email account. If you want to use things like Google, Gmail, etc., it's your choice. Bear in mind that if you use the same account in multiple sites, you could get locked out. It may block that because it detects that there's multiple IPs going onto the same network. It thinks that they're in different sites, so it could be looks like a hack, but it's in essence it's not. But you have to use it the right way. So notification class, you could add it, and then you can configure it, and we'll get into that a little bit later. I don't go too much into that, but notice that once you've enabled an alarm on an object, you do get this little alarm icon. And I did mention you could multi-select and multi-configure. So imagine I'm going to set up RTD thermistors. All of them are going to have alarms, right? And they're all set up the same way. I could also decide to, hey, let's also turn on trends. And now they all have trend logs available to them as well. And those trend logs are going to be listed right under the controller. So it's kind of like an extension, but it's an extraction of what's already possible within the controller for the object. And if you want to select all your trend logs and modify those as well, you can just go to the trend log section, which would be found right over here, and select them there. So we put them all in a list. And you could decide how many trends you want to collect, how often, and how many you want to hold in your buffer. So there's a 40,000 trend log record buffer in the controller. And the controller will hold about 250,000 records total. So bear that in mind. What we've done is we've made it work out to about a 7-day record holding. So 900 seconds with 672 records. That works out to about 7 days. So every 15 minutes we'll take a record. And that's typically a good value. But for those of you who want more, you could double that, get 14 days, you triple it, and you're still going to be well within, from this perspective, I think it's roughly around 370 points trended for a week. That's a lot of points to trend, maybe in a controller, maybe a plant controller, you're getting closer to it, but for typical applications, maybe you trend 50 points, maybe even that's saying a lot. So 50 points, you're looking at probably 5,000 records per point to get the 250,000 limit. And 5,000 records divided by your time base, you get to decide how much you want and how much time you want to hold on the controller. Okay. I could easily turn off everything I just did as well, like that. And so now everything is gone. Those trends don't exist anymore, and there are no trend logs available. So very easy to do multi point configuration. And a lot of the things we do are all based on efficiency of work. So we want to make it as easy to use, and we are open to recommendations. We have discussions with our vendors and our customers on what is needed. So we're going to go with this. So very simple space temp, and I'll hit OK. Every time you press OK, it does send that configuration down to the controller. You'll notice at the very bottom of the screen, it'll show that it's being sent down. If you don't want to send it down, it's work offline, the F10 button that you have to press, or just press that button. That stops or pauses all communication down to the controller. It's very important to note. Now, of course, this is a offline device, and if I don't wire anything to it, it will show me, electrical fault or something like that. But it's an offline device. I'm not even sure what it'll give me as an option. So we'll take a look at that next. So we've basically configured the space temp. Now, did we tell it what format to take? And that would be done in configure ports. Now, because I picked something that was known, it'll automatically bring out the degrees Fahrenheit. So that's fine. That's following in line with my project that was set up as US mode. Okay, you have the degrees Fahrenheit. Now, number override. So I could expose objects here, ports like that, or I can do them straight from show hide ports. So if I want to show the input ports, I could check those off. This is kind of like a show hide ports. Well, it is actually exactly a show hide ports for GFX. Okay, so we have here alarm set point. Had you enabled alarm, and this is all available again. F1. F1 is probably the best time saver when you're looking for specific information on a block. For example, this is an ECY or ECB series. And if you wanted to go look at, what does, what was it called? Set point, alarm set point mean, right? So if it's for a BACnet advanced application controller or a BACnet building controller only. So this is all our new stuff, of course. All of our current softwares will support that. We tell you what it does. So basically, it moves the set point back and forth by entering a positive or negative value to that alarm set point value. So you're not entering, I want 74 as a set point. You're entering, +4 or -4, and that'll move both set points. This is how it works. It'll move both set points for that alarm. So if my limit was 80 and I give it a 2, it'll be 82. If I give it a -2, it'll be 78. And likewise for the 60, it'll be 62 or 58. They'll both move forward and back with the value I put in there. Alarm inhibit is the same as setting it to a value from code space, but I could also visualize it and put it from the actual code itself. So you could just click and do that type of a thing. So at this point, I could go in and say, because I've added a binary value finally, I could pick the binary value as my inhibit value. So I don't have to link it anymore. This could exist on a totally different page, and it'll still inhibit that alarm. Okay, we'll leave those in there. We'll maybe play with those later on. Okay, and here we have output number. So number, which number? So this is the hardware input number 1. The override, this was our object that we enabled. Had we not enabled it, it would not exist. Okay, so you see it come up and out. So if I don't use it, maybe I have a sensor that does not have a push button. If I do have a sensor that has a push button, I'll select it, and that will give me a pulse on its output. Out of service, most probably this is going to be out of service because it's not connected or whatever, but typically this is your override. If you're overridden, it'll be put into out of service mode. Fault will tell you if it's faulted. Reliability, is it open circuit, shorted, etc. And then in alarm or not, this is your alarm point that you've said, nothing higher than 80, nothing lower than 60. So you could pick those alarm points and do something with it in code. But of course, we're already sending that over the network to a recipient That could be an EC boss. It could be any other ECY S1000. It could be another ECY VAV. It could be an ECB 650, you know, with a screen on board. So I could send it to anybody I want over the BACnet network. It's a BACnet alarm. So here we go. We're going to now create some code, and we're going to look at a little block here, like under HVAC, called thermostat. So a thermostat block, basically, very simply, input output check. I'm looking for the word, with a deadband. So if my input is higher and I'm direct, then I will turn on. If I'm lower than my set point, my reverse will go, and my deadband. So you could put a deadband in there. You have your set point, your deadband. Let me go and show hide these outputs here. I just want the output, input, set point, and some other object, something internal maybe, something that'll never change. If I want to change it from outside, I could always put in a analog value. But if I want it to be internal, I could add an internal constant like that. Now this will take a rebuild and send for any change to occur. You just push, select it, put the number you'd like, and these objects can be formatted. So we're going to format that object. We'll go into the configure ports, and I want the same format as I have for my set point and space temp. So I could right click on the format itself, pick from a recent format I've used in the past, or create my own, assign as favorites, pick them from favorites next time. So there's a lot of functionality here built in. So if I edit and I pick from an engineering unit perspective in this case, so we already saw Boolean, we saw enumeration. Now we're going to look at engineering units. You could go and pick from temperature, Fahrenheit, just like that. Now, the nice thing about using this versus a numeric value plus text, which is also an option, is this doesn't care what you have. So if I change the format of my code to be in SI units for another job I'm doing somewhere else, it's not going to change the text. Text is just simply stating a value it's just a string value. Your numeric value will change, but you may have 2 degrees Celsius this time, or 2 PSI, or 2 inches of water column. So you want it to follow, you would pick engineering units, and this will follow the project's engineering units. So there we go. Now it's degrees Fahrenheit, and it's listed there. It's nice to put. One of the options I showed Friday was the auto link, so the control Q, right? Or you just simply, here, I'll undo that, control Z. You simply select everything you want to connect. So you don't have to encompass them. You could just touch them like that. They're all selected. Right click on any of them and hit auto link. There's the control Q. And it'll link it in order of whatever it sees. So if I put these in the wrong order, it's not going to do it any more intelligently than that. Okay, so you got to put them in the right order. So if you really want set point to be the next connected, you got to put it in between, and you want to make sure that they're you don't have too many inputs, too many outputs configured. So if I were to configure ports and also have override, but I didn't want to use override, well, that's not a real good scenario for auto link. As you see, it took the next output. You can always move it. It's very simple. You pick it with the crosshair and just move it over. Click and drag and select. So you have that option. We could take these objects like that. We could change their size, make them all the same width. They'll take the width of whoever is selected last. So whoever's in red is the master selector. So now I've created some objects of the same type. I'll just put them like this. is how I like to use them here. And earlier we discussed collapsed. I can collapse an object so long as it only has one connection. If it has multiple connections, if I had another connection out here, it would not have worked. So if this was the scenario, it'll even tell me, you can't collapse it because you can only have one connection. So we're gonna get rid of that here. So this is really what you want to collapse. And so the reason we do that is just because it makes the code nice and easy to see on a single page. It saves us a lot of space. That one, I'm not using any of the other ports. So this makes it nice and easy. I usually put them a little bit spaced out like that. And they retain all of their object properties. So you can do whatever you want with those, just like you did earlier. Okay. Now we have our thermostat. We have our space temp. Let me put those back into full mode so you have a better view. Otherwise, you're looking at very tiny little objects. With our thermostat, and maybe want to do something on the output. So we can go back to the toolbox and pick out hardware input output, right? And of course, we could search for it. Hardware output using the search field. But if you've memorized it like I did, you could just go grab the hardware output, drag it onto the page. Or we could right click on direct specifically. And actually, we're not going to go to hardware this way, but we could go through other objects. Here's the hardware output. And this hardware output would be maybe our cooling valve or cooling on off, maybe. Okay. And again, we go into its interpretation and say, well, what kind of output are we using? So this is a universal output. It's the kind of I/O board we added earlier. It was the 8UI6UO. So we could do digital output. We could do pulse width modulation, 0 to 10 volts DC, or 0 to 20 milliamps. So if I go with the digital here, now I get all the options for this object. So again, it can be set to broadcast, local, global, COV. We have HOA. So if I have an object, if I have an I/O module that I've picked that was the 8UI6UO HOA, then I'll have the handoff auto option. So when I flick that switch, what do I get as an output? Do I get 0 volts? Do I get 10 volts, etc.? What is my default value, true or false, on or off? I can configure that to make it any other item I like. So on, off instead of true, false, why not? Yes, no, start, stop, right? So I'll go with on, off. If you want to make something else, you can also just type it in. So, we showed earlier running and stopped, but I could have done it here as well. So I could have said running and stopped. All right, so it takes it like that. The only drawback, and it's not really a drawback, but just something to note, is by doing this, you're not getting a enum file, XML, that you can't really import to your next job. So you can have to do this over again, or you'll have to rely on a favorite or something you've used in the past. But that's where that feature goes in. This is nice. It's a digital, so we also include a minimum on time and minimum off time. So anti-cycle, you set it up right in the object itself. This is a hardware output with a anti-cycle sequence built in. So even if I tell it to go on, if I have a minimum off time of 30 seconds and 2 minutes, whatever, 120, 300, I will stay off until this timer is expired. Reverse action or not, that's for the digital itself, but we're already covering the digital and reverse over here, so we're not going to re-reverse it. It doesn't make good sense, but you could if you want to do a reverse and a reverse, why not? Then you have, and also depends on how the object is energized, how the output is energized. Alarm. Again, we could set up the alarm. You could pick the same inhibit value we had before, or you could make your own, or you have none. Time delay to normal. And then because it's digital, you'll see its value being in alarm state or not. Trend log as well. And once we do that, and this is going to look for off normal to false and to normals. If you want to go with something more elaborate, you could maybe bring it into a binary value alarm to see if it's running and not supposed to be running, etc. You could build that logic yourself as well. So here we go, direct connection. And we've basically built see if I'm forgetting anything. We're going to start with debugging soon. Okay, so we've basically built a little thermostatic control valve. And at this point, I could start debug. That will build and send and save the code for me. So the debugging session cannot start unless the code is saved. And it's going to wipe out whatever's already on the controller. So you want to be careful with that, of course. Of course, we don't care. We're in emulator mode, but in real life, you want to work with that. And something I forgot to put was a output for my output. And this basically just best practice. You don't want to not know what's coming out of the output. Maybe somebody overrode it on and it's supposed to be turned off or whatever. So we could monitor all on that. We can also take it from the tools, just a monitor block. Now it looks a lot like the internal constant, but it's different. This one accepts an input. It does not have an output. And it just repeats what it receives. So you do it that way, or you right click and say monitor all, and that would monitor all ports that were on that object. Or I could have also right clicked on the object itself, right at the extremity of the port. So as you see, my crosshair or my cursor changes from an arrow to a crosshair to a dot with a black arrow. And you would see that like that. So it's really just the extremity of each input and output where that icon looks a little bit different. You right click and now I'll have this other option here. Whereas earlier, if I right clicked, I would not have link to. I would have either monitor all or auto link. And auto link we've already played with, monitor all we just saw. But if I right click on the port itself, so I'm saying this port specifically, I want you to link to. And now I decide monitor, internal variable, so like a buffer object that I could override or not, whatever, which stays internal. Analog value, binary value, multi-state value. In this case, probably makes sense to go with the binary value because it's the digital output. Again, I could override that binary value from the field, from the web page or whatever, before or after the hardware. It's up to you. And a reference hub, which hubs and targets. So reference hubs and targets are going to be what we're going to use to send data between pages. So if I were to take this object here, remember we created an outputs page. If we were to take this object, now instead of connecting it like that, I would cut it and I'll paste it on this new page. Now it's the same object, I cut and pasted it. Let me zoom in again. All right. Now I want to take data that I'm bringing from this side to the other page. Now I can't bring it there. I can't link it like that. The only way is think of it like link mark. That's what I'm doing here. I'm doing a link mark, reference hub. Now it takes the name of the object before and its port. This is why it says, hey, I'm thermostat.direct. Go to outputs, and I could do that link from. That's what that is. Link to, this time, reference target. Now, if I had multiple, let me use Control D here. I'll just do a bunch more, and I'll just call them whatever I want. Okay. I'll go to the input here, and I'll say link to reference targets. That's the, you know, the link from. Here you go. Now there's my reference target. Now, of course, I can name it here, but what you want to do is select it from a list of already existing hubs. The reason I created multiple hubs was just to show you that you wouldn't have just one option. You have an option of all hubs across your whole GFX project. So every single page within this project, this GFX code will be accessible through their hubs. So I'll pick that. And there we go. Now these hubs aren't being used, and I'm not going to use them. I can delete them. And when I go to this reference target, picking it from the list here, it's the same list we saw earlier. This time we only have one because I deleted the rest. And what's also interesting is that I could change this name. I could call this my cooling on-off command. Okay, and its target has also changed because they've been linked. Once they've been linked forever. They're lobsters. Just kidding. So we send that over. If I double click on the hub, it gives me a search field. It says, hey, this is where it's going. Of course, a hub can go to multiple targets. So that's why we expose this list, and you just simply double click it from the list and it takes you right to it. But if you're double clicking on the target, you're only going to have one hub sending to that specific target. So we'll take you right to it. Say, this is the one you're looking for. So they're always connected, and that's just like doing a link mark or NV link mark or whatever you want, and link to. Okay, so here's my on off, and we said earlier we wanted that monitor block, so that was the last option here. The first option, we just showed the last one. There's the monitor. Okay, so we understand that, and we understand that this works. If I press play now, all right, there you go, true running. And if I want to expose other ports, I could do some live changes here as well. Reliability, fault, out of service, in alarm or not, etc. Right? You do all these other items. Now I can't add ports or make changes to the code, but I could just change items in the object. I would have to stop this, right click, monitor all, and then push play again. That's fairly simple enough to do. It's just a step you have to take. Just you can't modify running code. You can't delete a line. I can't take this and delete it. Of course, you can break a lot of things. So it's got to be compiled. It's got to be analyzed and sent down. That's what happened here. So right now this is running. It's supposed to be running. If I go in there and say, hey, you know what? You're not going to run. I want you to be stopped, right? And it's false. This would show up with out of service true had it not been an emulator. It's only because it's emulator mode that it doesn't realize that that's there. But there you go. Now it went back to running, and we go back to auto. We're in alarm. Why are we in alarm? Let me go see here. It could be that I have no hardware. Let me see here. Configure ports. We'll have to see where that was. But that inhibit alarm, that's the one that would give us the ability to not or compare the value to something else and decide if it's going to be inhibited or not, to show that alarm or not alarm. But I think that's it for now. Let me put this back on the other page. We'll stop this. I could take this. I could move it back and forth if I like. I could cut it. I could put it back. And because they're on the same page, let me just make this a little bit neater. You could take this object here, and we have something called transform to direct links. Or you could take the line and transform to reference hub, connected reference hubs and targets. So that's an easy way to split up your code. If you have a lot of code already created and you want to, move things around, that's a nice time saver. Go back, reverse, control. There you go. Zoom out a little bit. There. So if I wanted to take certain things and put them on different pages, you could snip everything up, cut it out, and move things around if you'd like. So our next section will cover a fan. Let's go with the fan control. We'll turn this into a fan-controlled cooling thermostat. And to do that, we're going to add a second output. And it's going to be, I could add the whole thing, why not? We'll duplicate it. How many times do you want to duplicate it? Well, I just need one. I don't need 30 right now. There you go. And that copies everything. So that's something we could do. We can also do things like copy from. So if I had other objects that were configured the way I want them to be configured, I would get them in a list here. Say, for example, I had another hardware output in which I had configured that one previously as 0 to 10 volts. Notice when I did copy from, it also copied alarm conditions and all that. If I did a copy from, I would have two options, this one or that one. So this gives me the option to pick who I'm connecting to. It's a hardware output number 102. Whenever I drag in objects, whenever I duplicate them, I'm using this automatic increment to the next available. And this is something that's important for certain scenarios. Maybe you're an OEM, you're building your own project, and you want to bring in the same code every single time. You're building on multiple pages, but you want the same code on every page. You would select no auto increment. And when you would duplicate something like this, for example, you would have an exact duplication of the object. So there's no incrementation of the value. It would be increment to next, and that would be basically the next object. So 104 is available. And then to new, if I were to copy and paste this like that, it would give me another new object. Not sure where they went with the new one. That's something else I'm gonna have to look at. The I thought that would have been disconnected, probably when you drag out versus, but we get the idea using that increment. So I always use the auto increment, but again, if you want to duplicate or clone, you'd want to use a no auto increment. Okay, so there's our cooling on off. This is supposed to be called fan control, so it'll be a fan. We can call it on off. Now I'm using underscores, but you don't have to. You could use spaces if you like. They will, like I said, be eliminated when you discover the controller. The reason I use underscores is if I want to later on use display names, I could search for and replace with or without underscores, etc. So here's my fan on off. I will go with something of a control that will turn on that fan, and maybe something like a hardware input again, right? We'll go with hardware input, and we'll just use a simple 2 selection fan. Now this is repeated because we didn't erase all of our unused, so they come back with what they were configured as last, and this is okay. It's by design, but you can always remove them just like that. And now this time when I drag it in, it'll be because it's an emulator, it should have been set up the right disconnected way. But here we go with we'll go with the digital. We'll make an on-off. Okay. And I'll have this fan on-off select. All right. Now that'll work, but it doesn't do much other than turn on an input for an output. That doesn't make any good sense, right? We want to incorporate this into this thermostat's control. You want to have it turn on that fan and enable that object. So I want to have this ability to turn on or off the fan. And we're also going to bring in an OR block. We said we're going to use it earlier. I don't have it there anymore. No, I don't. So we'll go to logic, OR. Okay. And what we'll do with this is we'll take the fan speed select, so fan on off select, but we'll also take that override. So one of those two are going to turn on my fan, right? But this was a pulse. We said this is a pulse, this is a static, but if I receive pulse, so I don't care about what's happening with my fan selector, I don't want to go straight to the output because it's going to turn on and turn off unless I go with the min on time here. So that's something you could work with. So if I get a pulse, then you're going to stay on for 15 minutes or whatever. You press the button, half an hour, whatever. You get to put any time base you want. This will support a very, very large time base, but you can also work with something a little bit more feasible. We could go with a time block called min on off time. Okay, so now we take this output, and we could take it from here also and just drag it in, make that my input, and the output here would be my fan. My min on time, I can now decide from internal constant. I'll give it 15. Okay, 15 what? Well, that's depicted or described or controlled by the block itself, which you can go into the time base here and change it. Make it minutes, for example, or hours. And at this point, I'd probably want to configure this port and tell it that it is in minutes or seconds or hours. So I'll go into edit, select numeric value plus text, just type in minutes. Now let's go with engineering units, because if my time is usually not going to change, but it's okay to use units. Why not? And then I duplicate this twice, or yeah, I will need two, but whoops. Control D. I will need two, but one of them will not be minutes. So min on, min off. Min off time, maybe 2 minute off time for anti-cycle. And then your enable. This is basically one yes or no, enabled or not. So this will be a different kind of configure ports. Right? And this, I could use the Boolean on off. I could use the yes, no. Just like that. So it takes the number and it turns it into a selectable item that we could use. So the override will pulse into the OR will pulse out. It'll hold for 15 minutes on the fan. The space temp and set point will control the valve. So the fan will turn on, you press the button, you walk into the space, hey, I want fan, push the override, I got half an hour, I got 50 minutes or whatever. We could have an increment block or add block and start, every time you push it, you'll get 50 minutes, half an hour, 2 hours, 0. You go through a selector if you like, but you have options there if you want to do that. And maybe you also want to incorporate something like a schedule. So again, in time, we have a backnet schedule on board the controller. And you want to bring this into the OR block. Well, do I need to bring in another OR block? Absolutely not. We have up to 10 OR conditions. So every block is going to be, explained in the help file in F1 and all that. You can add more. You will see that you can have up to 10. Okay, and it's going to take a 0-1. It'll output a 0-1. It's an OR, it's not an exclusive OR, but we do have exclusive OR as well. And that's where it needs a even or odd number to be true or false. And it's got to be exclusive. So if everybody's true, then it's false. And if everybody's false, then it's false. But if it's exclusive, then it'll work. It's just logic. So here you go, current state. So now we could take a schedule or a fan control or a override push button to turn on the fan and eventually working with the controller. This is starting to get a bit more populated. So what we could do is we could line all these up as well. This is just making it look pretty. Okay, we could take this and why not make that a little bit more simpler? Turn it into a custom block. Now what that'll do is we'll put it in a block. It's kind of like a nested condition, nested if, those of you who are used to line by line. If this, then, else, etc. It's in here. So we now have this new piece of code that is giving us everything we had. Now these kind of look like what we saw earlier, those reference hubs and targets, but in reality, these are exported inputs and exported outputs. They're kind of like the composite, if those of you are used to Niagara, or a kind of dig deeper. So if you want to take data out of this page, because it's inside a block, the only way to get it to the outside is to export it. So we'd have to right click and use link to. This time, we have this exported output as a new item. You still have reference hub because you can go from this page to somewhere else on this page, always staying within the same block, but exported outputs allows you to go up one level. So by doing that, I now have a new object available to me over here, right? And if I take it out, so right now I have 3 here. I'll go back into the content, double click, view content. If I delete this, it is no longer available to me. So if we press play on this, go back to the home, play, this will work just the same. Now the difference between a custom block and a conditional custom block is one is just simply waiting for a condition to be met. in order to execute what's inside that block. Be careful with that one, because if the condition is not met, everything that was occurring in that block will be in stasis. It won't change. So you could have objects that are set to true and stay in true because you've never re-enabled that block. So that block will have to be either pulsed on, pulsed off, or rely on something and hope that, not hope, but program your code so that you're not controlling a hardware output right off of a conditional. If you lose that condition and say it shouldn't run, then it'll hold on its last state. So here we have our set point. We could right click, override, set values. Say we have a 73. So this should go off. There we go. Everything is off. My room is at 70. We're asking for 73. We got a 2-degree deadband. This is straightforward thermostatic control. I either bring my set point up or my space temp up. And let's say I bring my space temp up to 73.5. Hey, nothing happens. Why? Well, you have a deadband here. So let's bring it up a little higher. And 74, right? And there you go. So that's 2 is a band. It's dead band. So it's 2 degrees beyond both. So 1 and 1. So you have to take care of that when you're working with this. So here we go, 74 out of 73, true, etc. Of course, there's better ways to program into code. This has just been a simple example that we wanted you to see how to use the software, how to work with it. I'm just looking at my notes to see if I've covered all items here: override, schedules, fan on. Network value, I haven't checked that one out yet, but network value would have been another kind of input for this kind of code. So again, we want to incorporate a network value. Now a network value, we could again bring that into the OR block here, right? So how do I, now there is no unencapsulate. So once you've encapsulated something, you kind of have to go into it and create it yourself, or Control Z a few times. And hope you didn't. There you go, right? You could do that. And my OR block here, I will show another port. And I'll say either from any of those. Control E. Okay. That's encapsulate versus a conditional custom block, which is based looking for an enable flag. Otherwise, whatever's inside will not run. And this network value could be a remote occupancy command. Okay. And from who will that occupancy command come from? And you could decide at this point to either read a remote property or read a local property, remote object, if it was coming from another object, another device out there. You could subscribe, you could receive broadcast, right? If it was a read remote property, same deal. We could pull that object, we could subscribe to that object, COV, or we could receive the broadcast. So if there's an object out there, maybe you have a push button that you've brought into a VAV and you say, hey, this is going to broadcast. When I push it, everybody gets the same signal. I could set myself up to receive that broadcast. And there's many different ways you can configure your network traffic. It's a bit more of an advanced topic, but this is where you could do that kind of stuff. And you'd map it in. You tell it which device ID are you reading from, what object do you want from that device ID. So you can pick up accumulators, analog inputs, outputs, values, averaging, it's all kinds of stuff here you can go through. And based on that, which analog value in this case, and what do you want from that analog value? Do you want the time, the units, the reliability, the out of service, etc.? But typically we want the present value. but you have a lot of advanced logic if you want to do that ability. Read method, poll it every 60 seconds, every 300 seconds. When to subscribe it, confirmed or not. What's your subscription time? Your max receive time, your fallback, poll interval. So if I don't receive from you, do I fall back to a poll? And then what is my default value? Is it null? Is it something? And you can also trend your network values. So I don't even have to have the controller's point. So if I were to do something like a remote device or a remote value from another controller, so if we're thinking about setting up an S1000 as my master or my main controller that'll house all my graphics, I could, remember, we could remote trend all of our objects in every single other Eclipse controller, but I could also remotely, sorry, that's what I was getting at. I could remote trend all of my outputs without bringing in the point. So I don't have to discover the controller and then bring in the analog value and then put a trend point on that. I can actually trend my network value. I'll trend the remote device's value. And that's what this does for me here. Okay, again, the same setup as before. In this case, they're being trended in the S1000 because that's your master and that's where you're bringing those remote objects in. Otherwise, you would trend them all individually on those other controllers. So we have our network value or our schedule or our fan or our space temp override, sorry. Now I can't simulate the override because it's going to, I don't have that as an option. I only have the space temp override. This override is really a physical shunt of the sensor, but I could, of course, we'll have to fix this up because we're gonna have to come back and write so that my fan is going to work off of straight off of my command here. So we're going to have to take this value, bring it into another selector to make this really work. We'll go with a couple of select blocks or switches, I should say. Everyone loves the switches. So we go with a, how did I do this before? Fan is off. I got to get into the object itself because I need that OR block. You go with a link to export output. I'm going to call this my command. Okay. And we'll go with my command will be on. My fan will be off. No, sorry. And this will cover my select. Oops. This is where having a little bit more space wouldn't hurt. Now you can't draw your own lines, but you can move items around and have those lines create automatically for you. So you get to see them as they draw themselves, like that. Okay. And so now, did I forget something? Although even if I'm debugging, I could still move the blocks around. So you could draw these out a little bit better. Okay. So we have the off. I might have inversed these two, but you'll get the idea. I don't want to spend too much more time on this, but the idea here is that the fan will select based on a condition, and based on my set point and temperature offset, I will have those cooling and heating valves, sorry, the cooling and fan turn on at the same time. And that's it. That would be a small completed program. So I'll hand this off to Sam. It's taking a bit of time here. Give me a second. And we'll open this up to questions as well. All right, Sam, you're on. You're muted.
All right, thanks, Ab. Thanks a lot for the detailed intro into GFX and getting a bit into the weeds of things. So amazing. Thanks so much. At this moment, we'll open up for questions. So I know I've been answering them as they went, but if there's any other questions, we'll give you guys a couple of minutes to put them in and we can go ahead and answer them. All right, look at the chat. All right, so I've seen when using a custom block with enable, if the enable is turned off, the code does stop running, but the outputs are frozen at the last command. So if cooling were energized and the enable went away, the cooling will continue to run. Is this the way it is supposed to work? It's a great question. Seb, are you?
I'm muted. There you go.
There you go.
I was muted.
All right.
Yeah, so that's how it's supposed to work. It's by design done this way. So you can code around that. You make the sequences to what you need. We had to choose, and being a true condition, we wanted to freeze gate everything that happened outside of that block that was relying on code that was inside that block. If it was disabled, everything gets frozen. It doesn't revert back. You can, however, code to make things jump back to a null value or accept the next condition. So instead of directly connecting, you'd go into some other selector that says, this or null, and null means take whatever I was supposed to get. Hope that answered your question. There's a min on, min off time hardware point. Will prevent Niagara from writing to the hardware point once the point is being influenced by a min on off time timer. I think we write to the same priority 6 on that, on the hardware. So if we're saying no, it should not go unless you go life safety from Niagara. So that'll take over. Priority 1. No, we'll support all 16 priority arrays on those, on our device objects in ECY controllers. So that's the answer there, I hope, for you.
There's one if they want to, find out if they would add more than 10 ports to an OR block. We'll take that in consideration. I know that all of them actually max out at 10 ports, but we'll look into that if there's a need for more. So more details on that would be great. If you're able to post that on the forum, that'd be fantastic. On the what you currently use and why the need would be for more.
We also have other code sequences. We haven't showed it yet. We're going to get into those eventually, but I encourage you to look at the custom blocks or the custom code library. And there are scenarios where you could stagger OR statements. You could take 10, bring another 10. Since it's OR and OR, it's all the same. So it doesn't really matter if you have 10 ports or 20 or 50. You bring in 3, 4, or 5 OR blocks. It would accumulate to the same thing. Of course, that's different when doing different objects, but you could do whatever you want. It's just certain objects for size and reusability, they were limited from when we created the software. This is the same OR block, can use 10 ports from ECB, ECL, and ECY. So that had to be taken into consideration for future growth. Now, maybe one day we'll do something else, but for now, you could build your own staggered logic if you like. Any other ones?
The remote point, they want to go over the remote points again, but we'll be going over GFX quite a bit in the next couple of days again. Those of you that don't know, tomorrow will be preloaded, pre-engineered applications. So Matthew will be taking over that part and be showing a lot of that to us. So you'll get a bit more of that. Remote occupancy network point. Oh, that was the one from Brandon. Can you let us know where we can get a tape session for us to review this later? Absolutely. I'll go ahead and share my screen again, and I'll show you if we were to go to our forum. So if we go here and we go to forum.distech-controls.com, if you were to go directly to our website, again, we showed this yesterday, but I'll show it real quick again. Go to into the login section at the top right, and then scroll down and do access the forum. Once you select access the forum, if you're not already registered, it's going to come up with a sign up now. Go ahead and sign into the forum. Scroll down and you'll see one called video sessions. So the one we recorded on Friday, I've put up today, and we'll be putting this one up as well. So if you just select it, you'll be able to go into what we cover in this 90-minute video, which is the intro to Smart Installer, which was last week, starting the GFX program as well. And we'll post the next one as they come up. So that's the answer to that question. A couple of you asked that. We'll definitely put an itinerary up for each day as they come up. So right now we kind of quickly put this all together. So thanks to Sabatino, all the teams are on Distech to bring all this together so that we're able to show you a bit more about our solutions and products. As we create these outlines, we'll definitely share it with you guys. And at the same time, do not be shy. Please let us know if there's any topics that you'd like to cover. We'll be putting them in as they go. So, things from, how to start a station, best practices in Niagara, Eclipse as a small system. Tomorrow, Mathieu, again, we'll be going through pre-engineered, preloaded applications. So if you have more and more of these ideas, bring them to us, and we'll definitely go through them and bring them to you guys as we have this time together now. Any other questions? The approval process concerning the form, the process is you register, we validate that you are a direct customer or indirect customer of Distech Controls, and once that's validated, we approve you. So usually it's within 24 hours, you'll get approved, and then you can go ahead and register into the form, no problem. All right. Sad, do you see any questions you want to answer?
I think we're good. I'm looking. I'm sorry if I miss any. A lot of A lot of
think
text in here.
everyone's-
If
yeah,
you
let's
feel
see.
you haven't been answered, just reply right now. And just because there's a lot of back and forth on questions, so we just want to make sure without having to go through everything.
Yeah.
Any function blocks?
Niagara Analytics, yeah, so there is a session on Niagara Analytics directly from I think direct from their website through Tritium. They do have a quick session. I think by default you get the access to 25 points you can play with analytics. But as you get more and more into the analytics aspect of it, I think we'll let you know. We do have with Distech Controls, which is building OS. We'll be probably doing a session on that as well, so you guys kind of get a bit more on what Distech is doing with analytics.
So there's any function blocks we can do a first in, first out, last in, first out scenario. We'll have to look into that. It'll definitely be something that will be a custom, that will be a built-in code. So you have a sample and hold value. You put that into it's possible to be done. We may not have that specific scenario already set up, but I encourage you to look through our custom blocks in the code library, the stuff we share. The cleaning command, yes, we showed the cleaning command earlier. That was in the open configuration. It's depicted as a magnifying glass with little icon inside of it. You press that and you analyze the job. You select everything and delete. That'll delete anything that was not on a page or configured, or actually nothing that was on your GFX page. There it is right there. So Sam is displaying that. So you could reevaluate, you could select, you could delete, and all that. Any days with Nlight? There's a possibility. Yeah, we will be touching Nlight either through here or through the SSC channel. So I know I saw something of Nlight there.
Yeah, there is. So for those of you that know GFX quite well, I've been through GFX. On our website, we have the E901. So since Security Brands is a part of Distech Controls now, we have brought the Nlight world into the backnet world as well. If you want to know a bit more about the lighting world, starting from like what a Candela was, all the way up until how we've implemented Nlight into the Eclipse controllers, I really encourage you guys to go register on that via our website under training. It's the E901, and then it walks you through a full series of what solutions we have, what complementary solutions we have with GFX and Nlight, and that'll kind of get you up and running. But I think we will kind of do a quick session on, how does Nlight tie in together with the Eclipse controllers.
I love it. Some guys are already answering each other. Look, we have a live form happening right here. Yeah. So one of the questions was, quick link. I'm trying to get the output to go to a block, an object automatically. What am I missing? And it was basically, right-clicking on the output block itself near the extremity where the object becomes the cursor becomes a dot with a little arrow. We have a schedule of what's going to be covered each day. We are working on a schedule. This is live for us too, and we're trying to get something, somewhat of a agenda set up. So we are working on that. Working on tomorrow's agenda and then the day after. So that's what we do while we're not doing this. So we're working a day or two in advance right now. We're going to get better at it with our resources. And something of a real true binary out in lawn. Even though I choose binary, you still get a 0-100 out. Don't have to build a stat block or Niagara true false. So I'll have to look into that. It depends on what kind of snippet type you're using. If you're sending this out as an object, if it's a hardware output, you'd use 11%. Switch, which would give you 11% and state on off. Maybe use snippet state. Maybe you'd use snippet count inc. So I'll have to see what we're going to do with that. That's something we could maybe take off to the side.
Yeah. There's a lot of ways. There's a lot of voices skin a cat sometimes. So some of these things could be worked around, or understanding a bit more could probably give you more of an accurate answer.
Will the channel be working on EC boss station supervisor? Yes, eventually we're gonna show you an integration style. We're gonna use the create points. We'll bring in everything in and show you what it looks like with some graphics, maybe some Envision for ECNet, etc. So all that's gonna be
So
incorporated.
we're looking, I think on Wednesday, we're probably looking to do a bit of Niagara and, you know, the basics of Niagara. So the same way we did basics here, we'll probably do the basics in Niagara. We'll also start with an Eclipse controller, brand new. So these are all the type of ideas we're coming up with in order to, you know, do a lot of these sessions. And again, they'll be on the forum. So once this is, the recording is done, we'll send this off in the forum. You guys can go revisit this as well. And maybe Saib can even just maybe do a save of the code snippet that he has, and we'll add that in so you guys can go back and look at that code snippet. So we'll have all these available for you guys. All right, so we are kind of at 1:35. If there is no other questions, I want to thank everybody for their participation. It's happy to see it's extremely active. And again, if there's any topics that you want to cover, don't be shy, let us know, and we'll take them as they come.
Yep. Thank you, guys.
Have a great rest of the day, guys, and stay safe, and we'll talk soon.
Alrighty. Thank you.
Thanks.